So let's call this current as I3 this time, and we are going to keep this 2 ampere current source. So remove this 5 ampere source. Once again, the 3 ohms will not be playing any role, and this 10 volts will be replaced with a short circuit. So that's the resulting circuit that we have. You can see no more we can club this 6-3 ohms, calling them in series, because now there's a current source of 2 amperes connected across this particular 6 ohm. But you can easily make out that I can apply source transformation and club current source in parallel with the resistance and replace them with the help of a voltage source in series with the resistance 6 ohm. So if I do that, this is what we get. 3 ohm is playing no role, so I'll start my circuit directly from this 5 ohm resistance. This 6 ohm remains as it is. This is my 10 ohm resistance. 2 ohm comes here. Let us perform the source transformation. I will replace 2 amperes with a voltage source in series with the resistance 6 ohm which we have here. Because the current is flowing towards left, we will have to connect a voltage source that will also source current towards left. Current always comes out from the positive terminal, and hence we must have positive terminal first and then the negative terminal, because now if you verify, the current through this source will flow towards left, which will be in the same direction as this original current source, towards left. And in series we will have the same 6 ohm resistance. The voltage source value will be nothing but 6 into 2, that's 12 volts. And this is my original resistance of 3 ohm that remains as it is. My aim is to find out this current I3, that is through 5 ohm resistance. Now you can see that I can further go for series, parallel combination, source transformation, etc. But instead of doing that, let us quickly apply KCL at this point. Let me call this node voltage as Vx and find out Vx first and then find out I3. Because there is only one node, there will be only one variable Vx. So KCL, let me define 3 outgoing currents. The first current will be Vx upon 6 plus 5 plus 2. Everything is in series. So that will be nothing but 11 plus 2, which is 13, plus in the vertical branch the current will be Vx by 10, plus this will be Vx minus, because you are going from positive to negative terminal, so that's Vx minus 12 divided by the total resistance of 9, and this is equal to 0. Now this further will be equal to, if I take Vx common, I get 1 upon 13 plus 1 upon 10 plus 1 upon 9. And this minus 12 by 9 goes on the other side, becomes 12 by 9. This will be Vx into, if you solve for this bracket, so 13 inverse plus 10 inverse plus 9 inverse will come out to be 0.288, and this is equal to 12.9. So finally I get my Vx, that is going to be equal to 12 by 9 divided by 0.288. So that comes out to be 4.629 volts. But my aim was to find I3, so let's quickly go back to I3. You can see that I3, which is current through this branch, will be nothing but Vx divided by the total resistance at 6 plus 5 plus 2. So I3 will be nothing but Vx upon 6 plus 5, which is 11 plus 2, 13. That's the current we had also written here. So Vx by 13 is going to be nothing but 0.356 amperes. So that's my third value for the current I3. And now I've got all the 3 currents, so I can say that using superposition theorem, the total current I will be equal to I1 plus I2 plus I3. So let us quickly recall, my I1 was equal to negative current equal to minus 0.536, plus I2 was equal to 3.66, so let's add that, plus I3 that we just now got as 0.356. So therefore my final answer for current through 5 ohm resistance becomes 3.48 amperes. And we will also mention the direction, which is in the downward direction. So current that we had defined was flowing from A to B, and the value comes out to be 3.48 amperes.